Okay, Math 4 exam review, problems 21A through C. We're solving and checking each radical equation. So the first thing I'm going to do on A, since I already have my radical isolated, which remember the key is on these to isolate your radical, it already is, so I can simply square each side. When I square the square root, those two cancel each other out, and I have x plus 3 equals, and the square of 19 is 361. Now all I do is subtract 3 from each side, and I get x equals 358. Okay, let's go in and check this one. Remember to check, you just plug back in. So that's 358 plus 3 equals 19. Well, that's the square root of 361 equals 19, and of course that checks. It's correct. So we'll move on to B, which is a slightly more complicated one because I have something under a radical and I've isolated my radical on the left-hand side of the equation. So now I have to square it to get rid of the radical sign, but this time I don't have just one number. I have a binomial. So I have to square the binomial, which means I have to remember the rule for squaring a sum, or I have to put it side by side in FOIL. Here, these two cancel each other out. I have 54 minus x equals, and when I square the sum, I get x squared plus 4x plus 4. Remember, if you're not good at squaring a sum, just put it side by side in FOIL. Okay, now I'm going to move these over in this direction because I have an x squared that's positive here, so it lends itself better to movement in that direction. So I'm going to subtract 54 and add x. I'm going to subtract 54, putting them in the right order, and add x. Over here, they cancel out and I get 0 equals x squared plus 5x minus 50. Okay, so now I'm factoring that trinomial. I'm looking for what multiplies to negative 50 and adds to positive 5, which is going to be 10 and negative 5. So that gives me 0 equals x plus 10 times x minus 5. Remember, the rule is when you have two things being multiplied and they equal 0, one or the other or both are 0. So I take each of my factors, set it equal to 0, and that gives me x equals negative 10. Do the same thing for x minus 5. Solve that and I get x equals 5. Now remember, sometimes when you're solving radical equations, you can solve exactly correctly and get two answers, but one of them doesn't check. When you plug it back in, you get extraneous solutions. So you always want to be careful that you check this type. Over here we didn't have an extraneous solution, but that's because we didn't have a variable both inside and outside of our radical, and here you notice we do. So that makes it far more likely that we're going to have an extraneous solution. So I'm going to check negative 10 first. I'm going to plug in. Remember, all I do is plug it in. So I have 54 minus negative 10, which makes 54 plus 10, equals negative 10 plus 2. That gives me the square root of 64 equals negative 8. 8 equals negative 8. Well, that's not true. 8 doesn't equal negative 8, and that means negative 10 can't be a solution. So I'm just going to quickly try 5 without writing anything down. So let's see if you can follow behind me. I have 54 minus 5, which is 49. Square root of 49 is 7. The left-hand side of that equation is 7. Now go back. I had 5 plus 2 is 7. I got 7 here. I got 7 here. This one checks. So my answer is going to be x equals 5. It's a solution set, so I'm putting it in set notation. Okay, this one's a little more complicated because I have something under a radical sign. At the same time, I have an x on that side. The radical term is being subtracted, so I don't want to move my x over because then I have a negative radical. So I'm going to move this to the right and this to the left, because I do have to have an isolated radical. So let's start with adding the square root of 9 minus 8x to both sides. That gives me on this side x equals negative 18 plus the square root of 9 minus 8x. Okay, again, my radical has to be isolated, so that means the 18 has to go over. You could, of course, done this all in the first step if you recognized what you needed to do there. I just want to make sure you're all following along. So that's 9 minus 8x. Let me just draw a line here so you're not getting mixed up. Okay, so now I have my radical isolated, so I know that I have to square both sides. So just like the previous one, I have to square a sum, and when I square that sum, I'm going to get worse numbers than I would like to get. But I'm going to square the sum, square the first, that's x squared. First times last times 2 is plus 36x. And when I square 18, I get 324. On this side, I just get 9 minus 8x, because the square root sign and the square sign cancel each other out. This time I want to move the stuff in this direction because my x squared is positive over here. So I'm going to subtract 9 and add 8x. So that gives me x squared plus 44x plus 315 equals 0, because of course those two canceled out. So now when I go to factor this, x squared plus 44x plus 315, I'm looking for what multiplies to 315 and adds to 44. Multiplies to 315 and adds to 44. That's going to give me 9 and 35. So that's x plus 9. X plus 35 equals 0. Of course, I set each factor to 0 and solve, so I get x equals negative 9 and x equals negative 35. And remember, if you have a hard time getting these two numbers when you're looking for something that multiplies to a big number, prime factor and then play around with the factors. There was really only 4 factors here for 315. There was a 3 and a 3 and a 5 and a 7. So 4 factors, just play around with them until you find the right combination. Okay, so now I want to check this. I don't have enough paper here, so let's just quickly look at negative 35. That would give me negative 35 minus the square root of 9 minus 8 times negative 35. And whatever that is, it's going to be bigger than negative 35, so it's not going to check. What I get when I plug that negative 35 in was negative 35 minus the square root of 289, and that gave me negative 35 minus 17 equals negative 18. Don't want you to mix that up with my solve. That's my check, and obviously those two aren't equal. So that one is not an answer, and x equals negative 9 is the answer. Just remember that any time, especially when you have a variable both outside and under your radical sign, you're really likely to get an extraneous solution, so you want to make sure you check both of them. You won't always get an extraneous solution, but oftentimes that will happen, so you want to be sure that you check both of them.